Good day everyone. So for today I will discuss about the variable load by Darcy F. Guillermo base ME4A. So for the evaluation problems, a power plant is said to have use factor of 48.5% and the capacity factor of 42.4%. How many hours did it operate during the year? So in finding the actual hours of operation, the given are use factor is equals to 0.485 and the capacity factor is equals to 0.424. So the solution for this is the use factor is equals to actual energy output rolling of equipment times actual hours operation. Capacity factor is equals to average load over rolling of equipment. Use factor is equals to average load in which 8,760 hours over rolling of equipment times actual hours operation. Use factor is equals to capacity factor times 8,760 hours over actual hours operation. So we substitute the use factor and the capacity factor, which is the 0.485 is equals to 0.424 times 8,760 hours over the actual hours operation. So the answer and the actual hours of operation is equals to 7,658 hours. The next problem is a 100 megawatt power plant has an average load of 60 megawatt and a load factor of 70%. Find the reserve over peak. So the solution for this is plant capacity is equals to 100 megawatt, average load is equals to 60 megawatt, and the load factor is equals to 0.70, and we are finding the reserve over peak. So the solution for this, peak load is equals to average load over load factor. Peak load is equals to 60,000 kilowatt because we convert the average load of 60 megawatt to kilowatt. So the answer is 60,000 kilowatt over 0.70, which is the load factor. Peak load is equals to 85,714.29 kilowatt. So in finding the reserve over peak, the formula is plant capacity minus peak load. So reserve over peak is equals to 100,000 kilowatts because we convert the plant capacity, which is 100 megawatt, into kilowatts. So the answer is 100,000 kilowatt minus 85,714.29 kilowatt, which is the peak load. So the answer is 14,285.71 kilowatt. So the next problem is the annual peak load on 15,000 kilowatt power plant is 10,500 kilowatt. Two substations are supplied by this plant. Annual energy dispatch through substation A is 27,500,000 kilowatt hour with a peak load of 8,900 kilowatt, and a 16,500,000 kilowatt hours are sent through substation B with a peak load of 6,650 kilowatt. Neglect line losses. Find the diversity factor between substation and capacity factor the power plant. So the givens are plant capacity is equals to 15,000 kilowatt, annual peak load is equals to 10,500 kilowatt, annual energy in A is equals to 27,500,000 kilowatt hour, the peak load in A is equals to 8,900 kilowatt, the annual energy in B is 16,500,000 kilowatt hour, the peak load in B is equals to 6,050 kilowatt. So we are finding the diversity factor and the capacity factor. So the first one is the diversity factor. Diversity factor is equals to sum of individual maximum demand over max simulation demand. So diversity factor is equals to 8,900 kilowatt and 6,650 kilowatt because we get the peak load in A and we also get the peak load in B over 10,500 kilowatt, which is the plant, which is the annual peak load. So the diversity factor is equals to 1.48. In the capacity factor is equals to annual kilowatt hour over kilowatt plant capacity times 8,760. So the capacity factor is equals to 27,500,000 plus 16,500,000 kilowatt hour over 15,000 kilowatt times 8,760 R, which is the capacity factor is equals to 0.335. So this is the short discussion about the variable load. Thank you.